Okay, we're going to talk about compound events. But first we're going to start off with a warm-up on laws of exponents. So whenever I have an exponent to a power and then times the same exponent to a power, what you do is you add the powers together. So 2 cubed times 2 cubed is going to be 2 to the 6. Okay, and if I've got a number to a power divided by a number to a power, you can bring this up into the numerator and then subtract these powers. So 7 minus 5, it's going to give me a power of 2. Okay, you may want to look at this and check your work. Okay, let's talk about compound events. And if you ever want to spend extra time on something, hit pause and then watch it some more. Okay, so if I want to set up a grid diagram, I could look at all the possibilities. Here we got blue, blue, green, green, so I've got those choices right here. I've got red, 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 white, so I've got those choices right here. So the possibility of picking one of these balls is listed here, and then on a separate occasion, picking one of these balls is listed here, and so there are 16 different possible combinations with picking one thing from here and one thing from here. And picking something from here does not affect picking something from here, so this is called independent events. Because picking something from here does not affect picking something from here. So the probability of getting blue and then getting red is going to be 6 out of 16, because getting red and blue is going to be one of those 6 possibilities, and there's 16 total possibilities. Let's look at this example here. Probability of getting heads and probability of getting a 4. So you have a 50-50 chance of getting heads. You have a 1 in 6 chance of getting a 4. You've got 50-50 chance of getting heads. You've got a 50% chance of getting an odd number. So anyways, through these examples here, you can hit pause and look at it, but you're going to come to the conclusion that to figure out the probability of getting heads or tails and one of these situations with a die is simply this probability times this probability. So you have a 1 in 12 chance of getting a heads and rolling the number 4. And so on. So you may want to hit pause, look at this before going on to the next. So as mentioned before in our previous investigation, for independent events of getting something, we're going to multiply the probability of one thing times the probability of the other. Okay, and if I have 3 things happening, it's the probability of the first thing times the probability of the second thing times the probability of the third thing. So, for example, the probability of getting heads is a 50-50 chance. The probability of rolling a 3 is a 1 in 6 chance. So the probability of getting heads and rolling the number 3 is 1 in 12. Now, the probability of getting heads, then heads, then heads is 50-50 chance times 50-50 chance times 50-50 chance. Same thing with this. Tails, then heads, then tails, 50-50 chance, 50-50 chance, 50-50 chance. Okay. The school has 2 photocopiers. Chance of getting an 8% malfunction with machine A, and with machine B you have a 12% chance of getting a malfunction. So the probability that we get a malfunction is going to be 8% times 12%, and this is what we're going to have. Now, same thing. The probability of the machine not malfunctioning is this times this. How did I get 92? Well, if it's 8% chance of malfunctioning, it's going to be 92% chance of not malfunctioning. If I have a 12% chance of machine B malfunctioning, I'm going to have an 88% chance of not malfunctioning. 88 plus 12 gives me 100%. 92 plus 8 gives me 100%. So this is the probability of it not malfunctioning. Hit pause if you want to look at this more. Next, okay, dependent events. Okay, this is when the first thing that you do affects the next thing. So suppose we have a hat with 5 red tickets and 3 blue tickets. A ticket is picked at random and then set aside, and then a second ticket is picked at random. So if I'm going to pick a ticket and let's just say it's red, then I have a 5/8 chance that it's going to be red. Now if I've picked the red ticket and set it aside, now I've got 4 red tickets left, and I've got 7 tickets left to choose from because we took out a ticket and set it aside. So basically what's happening is the denominator decreases by 1 when we remove a ticket. Now let's say that the first ticket I pulled out was blue. I had a 3/8 chance of getting a blue ticket. So if I want to know the probability that the second ticket is red, I still have 5 red tickets in there, so it's going to be 5/7 of getting the second one being red. We're going to see more practice of this in the examples below. Okay, so dependent events. The first event affects the second event, and we're going to see this happening in all the examples we're going to do. Okay, so let's look at example 11. Okay, we have a box that contains 4 red tickets and 2 yellow tickets. 2 tickets are chosen at randomly and without replacement. So what's the probability that both tickets are red? So 4 red tickets out of 6 tickets, so we have a 4 out of 6 chance that the first ticket is red. This is the proper way to write it. This is saying the first ticket's red, then the second ticket's red. So we have a 4 out of 6 chance that the first ticket is red. Now I've taken that ticket and pulled it out. So now I've got 5 tickets left, and 3 of them are red. So my probability that both are going to be red is going to be 12/30. Now the probability that the first ticket is red and the second ticket is yellow. So once again, 4 out of 6 chance that it's red. And then the second one, we still have 2 yellow tickets, right? So then 2 out of 5. Okay. Then I've got a box that contains 4 red balls and 3 red balls. And 2 balls are taken out without replacement. So probability that they're both red. So we start off with 7/10. Now we've taken a ball out. Now it's times 6/9. Here we start off with first one's green, second one's red. So 3/10 and then 7/9. Okay, probability that you're going to get 2 boys. There's 2 girls and 5 boys in a group, so we have 5/7. One of them's taken out. Now we've got 4 out of 6. Multiply those together. That's the probability of getting 2 boys. Question B was a little tricky. The probability that we get 2 of the eldest humans. Well, there's 7 humans to choose from, and we have a 2/7 chance that we pick one of the 2 oldest. Now that we've picked one of the 2 oldest, the oldest is still left, and so we have a 1 in 6 chance of picking the next oldest person. So you may want to hit pause and listen to this again if you have troubles. And that's it.